Thank you. My name is Pete Losee. I'm Director of Technology Development at United SiC Carbide, and I'd like to talk to you briefly today about getting the most performance from your silicon carbide FET. Getting the most out of silicon carbide requires you to minimize losses and reduce cost. At United SiC Carbide, we do this with a cascode FET, shown in the figure in the middle. In this structure, we use a very low on-resistance trench vertical JFET built in silicon carbide in cascode with a low voltage silicon MOSFET that's engineered for cascode use. This allows us to avoid the major problem of channel resistance that plagues the silicon carbide MOSFETs because of the poor inversion mobility. We make use of the near ideal inversion characteristics of the silicon MOS. The ultimate result is a very low specific on resistance, as is shown in the chart on the right. Here I'm representing the 750 volt Gen 4 device versus temperature, along with our previous generation 650 volt devices and the best in class 650 volt silicon carbide MOSFET. You can see that silicon carbide JFETs have less than half the on resistance per unit area than do silicon carbide MOSFETs. This allows us to deliver 2 times more chips per wafer, or a lower output capacitance COSS for a given RDS on. It's often useful to compare different technologies using a figure of merit. In this radar chart, I've normalized the figures of merit back to a 750 volt Gen 4 United silicon carbide FET. Here we can see the lower RDS on per unit area at all useful temperatures, a lower dead time loss afforded by the lower integral diode VF, a lower RDS on times EOSS figure of merit, which is important for hard switching efficiency, and a lower COSS time related times RDS on, which is important for high frequency soft switching applications. All these performance benefits come with the additional benefit of easy gate drive. Our devices allow you to drive just from 0 to 12 volts, but our plus or minus 20 volt range ensures compatibility across whatever technology you may be using now, such as silicon superjunction, IGBT, or silicon carbide MOSFETs. I'd like to now point you to our website so that you can see what United Silicon Carbide FETs can do for your application. This is made easy by our new FETjet calculator. You can evaluate a full range of our products, both FETs and diodes, in a variety of power electronic applications. All the relevant power electronic topologies are represented in the tool. This will give you instant results and help you make design decisions, calculate efficiency, look at component losses, junction temperature rises, and do a component optimization both in part count and selecting the right product. One of the applications you can find in the FETjet calculator is Totem Pole PFC. In this chart, I'm showing the recent results of our Gen 4 750 volt FETs in a 3.6 kilowatt Totem Pole PFC. We achieved a peak efficiency of 99.3%, and in the bar chart on the right, I'm showing the loss in the fast leg switch. At 100% load, the loss is about 8 watts, so for 16 watts across the entire leg, it represents about 0.44% loss. With these low losses, you can minimize your heat sinking. You have the added benefit of a simple 0 to 12 volt gate drive, reducing the overall system cost. Thank you for your time, and if you have any further questions, you can find my contact information listed on this slide.